Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. In the previous session, we have discussed about the searching and what are the different types of searching techniques, and in this we will be seeing the overview regarding the binary search and examples on binary search and its implementation. All these three concepts we are going to discuss in this session. Let us come to what is a binary search. As we have seen in the example of linear search, we are going to search the element in a sequential fashion. Because of that, the time complexity also we have seen. For linear search, the time complexity in best case is big O of 1. And average and worst cases are big O of n, right? These are the two things which we have seen already. And now, how the complexity is going to be reduced by using the binary search algorithm. In the same way, we are going to read a list of elements, read the search element from the user, the same process, but here find the middle element in the sorted list. Here one condition you need to remember about the binary search is we need to read the elements only in the sorted order, but we don't have any condition for the linear search, okay? And find the middle element in the sorted list. From that sorted list, whatever you are going to take, from that find the middle element. How we are going to find the middle element? We are going to take it by taking the low plus high by 2. By doing this, we are going to find the middle element. Compare the search element with the middle element in the sorted list. Now, we are going to compare the middle element which you are going to find it from the sort, that is the search element with the middle element. If both are matching, then we are going to say that given element is found in the list. If both are not matching, then check whether the search element is smaller or greater than the middle element. What are the search element we are going to take, whether it is lesser than the mid element or if it is greater than the mid element we need to search for. If it is lesser, then we need to search this repeated process. We need to repeat this process only on the left hand side. If it is greater than the mid element, we are going to check only on the right hand side of the list. That is called the right sublist we are going to check for. If the search element is smaller than the middle element, repeat steps 2, 3, 4, 5 for the left sublist of the middle element. Otherwise, if the search element is larger than the middle element, then repeat the same steps on the right sublist of the middle element. And let us see, these are the steps which we are going to solve it with an example so that you can understand very easily. Repeat the same process until we find the search element in the list until sublist contains only one element. This is going to be done until you are going to get a single element in the list. We are going to repeat this process. If that element also does not match with the search element, then display the element not found in the list and terminate the function. If you are doing all this process, whether it on the left sublist or right sublist, all this has been done. If the element is not found, then we are going to say that element not found in the list. This is the algorithm where we are going to use for our binary search. And this is the example. Consider the list of elements and the search element is same 12. I have taken the previous one also we have seen the linear search, the same list of elements I have taken. Now, you can search for the element at 12. Now, what we need to do? We need to find the middle element. How you are going to find the middle element? Mid equal to low. Low is nothing but this part. Low plus high. That is 8 by 2. That is nothing but 8 by 2 is nothing but 4. Now, this is your middle position, right? And the element which is present at the mid position is 50. Now, compare it with 12. Both are not matching? No. Now, both are not matching. Now, 12 is smaller than 50 or whether it is greater than 50. Now, we need to check for that. 12 is lesser than 50. So, that we need to check in the left sublist. We need to check in the left sublist. So, that we need to modify the mid position. We need to modify the mid position. Again, we need to compare with the mid position, right? From here to here, we have already done. This is your mid position. Now, the remaining elements we need to search for. Now, this is called the low value and this is called the mid minus 1 and this position is called the mid plus 1. Now, when you are doing this, we need to adjust our low and high values. Now, at the starting, your high value is this. Now, I need to check only on the left hand side. Left sublist, I need to verify. That's why we need to adjust our high value to mid minus 1. This has to be done. Now, from this, what is your low value and high value? Low value is 0. High value is 3 by 2. 3 by 2 is nothing but 1.5. But don't take the decimal value. Take only the integer part, so that you are going to get the mid value as 1. Now, we can able to find the position of a 12 at a position 1. Like this way, we are going to perform the binary search. In the same way, you can search for the element 80. In this case, you need to search with the middle element, and you are going to compare the element on the right sublist. For showing you, I have placed this example. Now, you can see here, this is where you can implement the binary search. As usual, you need to read the array elements in the sorted order and read the size of your array. First, read the size of array and read the array elements in the sorted order, and then read the key element. Key element is nothing but the search element, right? And initially, we need to initialize low equal to 0 and high equal to n minus 1, and we need to find the mid value, right? And repeat this process. I have mentioned only without using recursion here. With recursion also, we can write the program. And here, all these things we have to do it in the main function. And this function, we are going to call it in the main function. And this one is going to return some value back to the main function, so that based on that we can say that element found at a particular position. And when you are going to write this logic, observe how we are going to do the modification. If low value is less than or equal to high value, in this case only, we are going to find the mid equal to low plus high by 2, as we have seen in the previous example. Low value is 0 and high value is some 8 by 2, that means the mid value is 4. And we are going to check with the key value and a of mid value. Yes, mid value and the key value both will be verified. If both are matching, we are going to return that mid value back to the main function. If key value is lesser, then we are going to adjust our high value to mid minus 1. Otherwise, you are going to modify. If I want to check it in the left sublist, I need to adjust the high value. If I want to check it in the right sublist, then in that particular case, I need to adjust the low value, low equal to mid plus 1. That is without using a recursion function, and this is based on the recursion function. In recursion function, we are not using any loops. Please remember this. Here we are going to use only if and else statements. How this will be easily done? The same thing, low should be always greater than high value, and if it is the case, it has to return minus 1. If low value crosses the high value, then it has to return the minus 1. This is a base case, and you are going to find the mid value, the same procedure, low plus high by 2. And when you are going to have x equal to a of mid, if this is the case, you are going to return the mid value. Otherwise, x less than a of mid and other one is x greater than a of mid. The search element is less than or greater than these two conditions we are going to verify. But in the previous case, we have done them separately, that is by using a loop we have verified. While loop we have verified until low less than or equal to high, we have did it. But here we don't have any loop, because of that we need to call the function recursively. When it is lower, that is search element is less than a of mid, in that case we are going to adjust our high value. Those things also we need to pass it here. A is the array, x is the search element, and low represents the left sublist, and mid minus 1 represents the list which we have adjusted, that is high we are moving it to this position. And if I am going to search an element on the right hand side, a value, x value is the search element, mid plus 1 represents the position of low value which you are going to search the element on the right sublist, and high will be at the same position. Like this way we can perform the program or implement the program by using recursion also. And if you can see the best, worst and average time complexities here the time complexity is reduced because we are not we are not supposed to search all the elements in the list. Either we can search the element on the left hand side or right hand side. Because of that, the time complexity is going to be reduced. Here the same case, the best case is item in the middle. If you are going to divide the list and if you are going to find the element in the middle itself, then we can say that the time complexity is big O of 1 only. And the worst case and average case both will be taking big O of log n by 2. That is, it is reducing when you are compared with the linear search, that is big O of n. Big O of n is larger than log n by 2, right, log n base 2, right. Here the time complexity will be reduced in the binary search because we are not searching all the elements in the list, right. Either on the left sublist or right sublist we are going to search. Based on that we can decide that whether the element is there in the list. If the element is present, we return its position. If the element is not present, we are going to return element not found. This is how we are going to implement or perform binary search analysis. I hope you understand this, and let us see what is the summary of today's session. Here we are going to discuss, we have already discussed about what is binary search and examples on binary search we have seen, and we have seen the implementation of binary search also, and with this we have discussed about the analysis, that is time complexity, how much it will take for binary search. I hope you understand this concept. Thank you.